All right, hi everybody. This is me, and it is Wednesday. Juniors, good luck on that outline. Look forward to you crossing that finish line this Friday. All right, we left off here in class. Now, I didn't copy everything down, but this was the function f of x. Please grab that notebook out. We made our list of rational root candidates, and we divided and conquered, and I think Team Scout found that -3, when I use -3 as the root candidate and I do synthetic, I land here, remainder of 0. Yay, okay? Now, we're going to do this. What that tells me is the following, okay? X equals -3 is a root of f of x. And what that also tells me is that x plus 3 is a factor of f of x. Okay, and what I'm going to do now is I'm going to rewrite f of x, because here it's standard form. I'm going to rewrite f of x now in at least partially factored form. I know now x plus 3 is a factor, and then I'm going to grab these coefficients here. The other factor is 2x cubed minus 5x squared minus 2x plus 2. And again, why is this cubed? Well, because the original function was degree 4, and when I take a degree 4 here and divide it once by synthetic, down here we've got a degree 3, the result. All right, so now here's where we are. We've got now, our focus is, maybe can we break this down further? So I'm going to take a look at this one, okay? And I'm going to list those coefficients. Right, and those are just here, by the way. I just kind of grab these. They're now down here. And I'm going to continue chipping away, because remember, what I want is to get this down to a degree 2. Once I'm down to a degree 2, I can work with it, right? Now, here's what's beautiful about this is, you know, we made our pool of rational roots. That pool of rational roots is the same pool of rational roots for this, because this, after all, is just a factor of f of x. So the things that we ruled out already, we don't have to try it again, right? So that's good. What I'm going to do here, and this is what I'd like for you to pick this up as a habit. You know, I know that -3 is a root. Here's what I'm going to do, everyone. I want to try -3 again. Why am I doing that, everybody? Well, I just want to rule out the possibility that -3 is a root of multiplicity beyond just 1, right? So here I go. Synthetic away, synthetic away, synthetic away. Yep, not looking good, is it? Yeah, I'm not even going to finish, right? The point is, I know this is not going to be 0, okay? All right, so now I know -3 is not a root of multiplicity beyond 1. Okay, now here's where I think I actually have to rewrite all the root candidates, because I have to remember which ones we tried. So bear with me here. I'm going to pause for a second. Okay, here I am. So what I did was I just went and found my candidate pool. Now, correct me if I'm wrong, everybody. I believe we knocked out, we tried the positive -1, we tried positive -2. Did someone try positive 3? I think they tried positive 3. I'm just going to try just in case here. All right, let's try positive 3. Let's not lose ourselves in our work here, okay? We're at this place. Let's try positive 3 just to make sure. So I'm going to do a little. All right, 2, -5, -2, 2. 3 is the root candidate. Let me just roll this out. 2, 6, 1, 3, 1, 3, okay, 5. All right, so then let's go back here. So we've knocked out positive -1, positive -2, positive -3, positive, okay, so that what's left to try, oh boy, we have to try these. You know what? Part of me wants to leave the fractions for last, but then I'll tell you something. You know what? Part of me also feels like in some sick and twisted way it's possible that positive 1/2 may work. So let's just try it. Why not? Here we go. Let's try positive 1/2 as the root candidate. Here are my coefficients. Why not? Why not? Let's just buckle in. Let's do it. Add 2, I mean, bring down the 2. Okay, 2 times a half is 1. So negative 4. Negative 4 times a half is negative 2. This becomes negative 4. Oh my goodness. Happy, happy day. Yay. All right. So let's continue the story. I have to shrink myself down. Yay. So I've gotten even more information. So that means now I can say f of x is, all right, the x plus 3 is there. Then I have x minus a half, right? Then I get, yay, this right here is going to be degree 2, okay? So then I have 2x squared minus 4x minus 4. All right, let's keep going. Now at this point, I'm looking at this. Let's see if I can further factor this down. Do you see a GCF here? Whenever there's a GCF, we're always going to pull it out. Okay? And generally speaking, everyone, when there's a constant factor, what we usually do, what you'll normally see is the constant factor just sits up front. Kind of takes the driver's seat, just because it looks neater that way. All right, now I'm looking at, so here's where I am, my latest, most factored version of f of x. Oh, big fat bummer. This is not factorable. So I've got to go over here and solve for my roots. I have a sneaking suspicion. Let's see, quadratic formula, x equals negative b plus or minus the square root of b squared, so 4 minus 4 times 1 times negative 2. So plus 8 all over 2. Oh, outstanding. 2 plus or minus radical 12 all over 2. All right, x equals 2 plus radical 12 over 2, and x equals 2 minus radical 12 over 2. I'd like to ask you all a question. Are these two roots unreal or are they real? No, these are very much real. These are absolutely real. They are real numbers. They are real roots. Now, they are real roots. They happen to be irrational, but irrational we can deal with, okay? All right, so let's take a look here. Let's make my work nice and neat. Final roots, the roots of f of x, they are right here. X equals 2 plus radical 12 over 2. X equals 2 minus radical 12 over 2. X equals negative 3. X equals 1/2. Look at that, everybody. Have I found all the roots? Fundamental theorem of algebra, it says if you count multiplicities and irrationals and the unreals, we should have, let's see, what's the degree of f of x? Where's the beginning of my story? Yay, look at that. Degree 4. I have found all 4 of my roots. Now, what I want you to do down here is, for the purpose of graphing, we're going to roughly estimate this. Rough estimation, radical 12. Radical 12 is just shy of what number? It's kind of like between 3 and 4, right? So maybe here, for the purposes of graphing, you'd make this 2 plus 3.5 all over 2. Maybe 2 minus 3.5 all over 2. And then we're going to sketch it, everybody. Pause me right now and do your sketch, then replay me. We're going to see whose sketch is better, mine or yours. Okay, pause me. All right, here I go, my sketch. Negative 3. There's a root right there. Positive half is a root. 7.5 divided by 2. It's going to be between 3 and 4, maybe here. And again, we always label it exactly. Okay, 2 minus 3.5 divided by 2. We're looking at about negative 0.75. And again, we always label it. Okay, what's the y-int of this bad boy? Y-int, y-int, y-int. Y-int is positive 6. Here we go. I'm going to be play a little loose and free with my scale. Lead coefficient is positive. Okay, that means my right end is going to rise. Degree is even. Right end is going to rise. All roots of multiplicity 1. Pass straight through, pass straight through, pass straight through, pass straight through. Oh dear, I missed. Make that bigger. There we go, everybody. Okay, so that was the conclusion of our conversation today in class. What I'm going to do is post your homework on the teacher page, and hopefully you did this in the correct order, which is listening to the screencast first, and then doing the homework in the book. All right, everybody, I'll see you Friday. Goodbye.